This is lesson 514, which is inequalities. So we were just in unit 6, but we're going to jump back to 5 just because we have limited time here. I'm going to start going through and picking out what the priority standards are. So what those things are that you really need to know that are the most important before you go to 7th grade. So we're going to finish 5 and then go to unit 7. So 514, inequalities. This is 4 pages of notes, but they're all really spread out, so don't panic. Although there are a few definitions in here. So let's get started. An inequality. An inequality is a statement that compares two expressions using one of these symbols. Make sure my whole notebook's in here. Okay, so just show all of these to you. This is a review for you guys, but we'll get more in depth with it this year. So we have the greater than symbol, greater than or equal to. Equal to has, I think of it as 1/2 of the equal sign underneath it. And so for these greater thans, you can remember that the larger number is always going to have the opening facing towards it. So I remember the crocodile or the alligator. He always wants to eat the bigger number. So when it's facing to the left here, just because we read left to right, that makes the number on the left greater than the number on the right. So greater than is open to the left. Our next ones are less than and less than or equal to. Again, the less than or equal to has this half of the equal sign underneath it. And then we have not equal to, when two sides of the two expressions on each side are not equal. Okay, so I have some examples for you and then how to say them. X, again, we just read left to right. So I think you guys will be really great at this because when we were doing the algebraic expressions, you did a good job. X is greater than 5, and then I just wrote it out there. Again, just reading left to right. T minus 3 is greater than or equal to. I have a greater than with the half of the equal sign under it, or equal to 15. 12 divided by 2 is not equal to 3. And that is a true fact. 12 divided by 2 is 6, which does not equal 3. And 8 is less than or equal to 3 times k. So just reading those left to right and practicing the words of how I would say them. Right, on my next page here. The solution of an inequality. So we know that a solution is an answer. Okay, an answer that works. So a solution of an inequality. If an inequality has a variable or one of those letters in it, the solution is a value that can be substituted for the variable to make the inequality true. So let's look at some examples of that because I think that this might be hard to understand unless you see what it is that we're doing here. So for example, X is less than, I know that that's less than because it's pointing to the left and open to the right. X is less than 12. So my X here could be 9. 9 is less than 12, that is true. My answer could be 11.99. 11.99 is less than 12, that is true. My answer could be 3. 3 is less than 12, sorry. That's true as well. So what is something that is not a solution? Something that would not be true? How about 15? 15 is less than 12. 15 is not less than 12, so that is not a solution. That is not true. So I just want to point out here, for instance, this one, I gave 3 examples, but I mean, I could have picked anything that was less than 12 in there. So there can be many solutions, and we're going to talk about that more later too. Okay, so there's not necessarily, I mean, there is a wrong answer, but there's so many right answers. Here's another one. P is more than or equal to 7. So I need things that are more than or equal to 7. So how about 9? 9 is more than or equal to 7. Yes. How about 1,000? 1,000 is more than or equal to 7. Yes, that is true. For this one, how about 7? 7 is more than or equal to, has to have that equal to sign right there to be true. I'm actually going to highlight that. Equal to 7. Okay, so let's look for something that is not a solution here. How about 5? If I said 5 is more than or equal to 7. No, 5 is not more than or equal to 7. So that is not a solution. Just have a couple more for you here. 3m, so 3 times m, is less than or equal to 12. So I need to come up with things that are multiplied by 3 and are still less than 12. So how about 2? 3 times 2 is 6. That is less than or equal to 12, so that works. How about 4? 3 times 4 is less than, well, 3 times 4 is 12. And is 12 less than or equal to 12? Yes, it is. And it has to have this equal sign for that one to work. 3 times 4 is less than or equal to 12. That's true. So something that is not a solution, let's try 5. 3 times 5 is 15. 15 is less than or equal to 12. That is not true. That is not a solution because 3 times 5 is 15 and that's greater than 12 and also not equal to 12. Okay, I have another example that's worded in a little bit different way. Is P equals 2/5 a solution for 5P is greater than or equal to 2? So don't get overwhelmed with how wordy this is. You guys have the tools in your tool bag to do this. So if I want to substitute 2/5 here for P, I'm going to be doing multiplication. This is multiply because there's no space there. So if I want to multiply a fraction, I know that I need to put the 5 into fraction form. So the 5 will be over 1 times 2/5. So I just subbed in my P right there. And I want to know, is that more than or equal to 2? So I'll do the math here. 5 times 2 is 10. And 1 times 5 is 5. Is that more than or equal to 2? Well, this is an improper fraction. So I need to change this into a mixed number or a whole number, depending on how it works out. I could also just look for, well, a lot of you guys probably see what the answer to this is, but I'm just going to follow the method that we usually use. 5 goes into 10 2 times. So you may be able to recognize this 10 over 5 as 2. So is 2 more than or equal to 2? Yes, it's equal. Have to have that equals part in there for this one to work. So is 2 over 5 a solution? Yes, it is. Because these multiplied together equals 2, and we do have the greater than or equal to 2 right there. Let's do it with this. Is p equals 1/10 a solution for 5p is greater than or equal to 2? So I'm going to set this problem up the same way. 5 over 1 for my 5 right here, times p, and I'm subbing in 1 over 10, greater than or equal to 2. Now I'll multiply. 5 times 1 is 5. And 1 times 10 is 10. Is that greater than or equal to 2? So I have 5/10. Again, you might just recognize this as the solution I'm ultimately going to get to, but I'm going to see if I can reduce that at all. Let's see. I can divide both of these by 5. They're both a multiple of 5, and that leaves me with 5 divided by 5 is 1, and 10 divided by 5 is 2. So 1/2. 5/10 is 1/2 when we reduce it. So is 1/2 greater than or equal to 2? No, because 1/2 is less than 2. So my answer for this one is no. Okay. If that was too fast for you, I just realized I was talking a little bit fast since I had those written out. You can go through and listen to it again. Okay, graphing inequalities. So I highlighted this one and gave it its own little section because this is really important. This is what we actually do with the inequalities, or one thing we can do with them. Okay, infinite solutions. Something infinite goes on forever. Most inequalities have infinite solutions, and it would be inefficient to list them all. For instance, in p is more than or equal to 1, my p, it just has to be more than 1 or equal. So my answer could be 1, 1.1, 1.12, 1.13, 1.132. I could go on and on forever, going out as many decimals as I could. It would take forever, and it includes all of those. All of these things are more than 1 all the way up, well, forever. Okay, so do you see how that would be just inefficient? That wouldn't make sense to try to list all of those things out. So we're going to come right back to this in just a minute here. I have another term for you, which is the solution set. So the solution set of an inequality is a collection or a set of all of the possible solutions. So it's all of these numbers are the solution set. But like I said, it wouldn't make sense for us to write all of these out. It would take forever and give us just way too much data that we didn't even need. So how can we show a solution set of infinite solutions? With a graph. And that's what we're going to practice today on the homework, and then I sent another sheet for it as well. All right, I have one more little definition for you, which is a ray, R-A-Y. It is a part of a line that has a starting point but no end point. So you can see right here I have two different kinds of rays, one with a dot that's filled in and one with a hollow dot. So these are its starting points, and it's a point. And then the other end has an arrow. Because it doesn't end. It just has the arrow to show that it's going on and on. Okay, so this is a ray, and this is what we're going to put on our graph. So this is what these look like. Okay, here's our inequality symbol. The words for how we say it. We'll do what its ray looks like, and then an example right here. So for greater than, its ray is going to look like this. It's a hollow circle on the point where it starts, and then it points to the right. Hollow circle at the point that it starts, and then it goes to the right. And I'll explain to you in a little bit why it is that it's hollow. So for example, x is more than 1. So I know, like I had on the other page, x is going to be 1, or not 1, it's more than 1. So it's going to be 1.1, 1.2, 1.3, 1.4, all the way up to 2, up to 3, up to 1,000, up to 1,000,000. It's everything that is more than 1. So because this is greater than, it's going to have a hollow point starting its ray right here on 1, and then go to the right with the arrow at the end showing that it goes on forever. So now instead of listing out all of those infinite solutions, I've made it really simple by showing it's greater than, and again, I'll tell you why it is that this is greater than 1. That's a much simpler way of showing that it includes all of those numbers. Okay, less than is also going to start with a hollow point, and its ray will travel to the left. So here I have x is less than 2. So it's going to be everything that is less than 2. It's going to be 1.9, 1.8, 1.7, 0.01, negative 1,000, all the way this way to the left on the number line. So I'll start it right here at 2 with my hollow point, and then my ray travels to the left, including all of these numbers that are less than 2. Okay, now we have greater than or equal to. Greater than or equal to. This ray is going to look like this. This point is filled in, and then it travels to the right, just like this greater than one did travel to the right. This one travels to the right as well, but this one is filled in. So the way that I've remembered this always since I was your age when I learned this is I think of like this equal to as being something extra that's added to just the regular greater than and less than. The equal to is extra, and so the extra part of it fills in the circle. So if I think of there as being two different things, like an outline and then the filling, this is extra, so it fills in that outline. I don't know if that makes sense to you guys, but that is how I have remembered this my entire life. So when it's equal to, it's going to be filled in. Let's see, how could I? And these ones are hollow. This has two parts to it, a greater than and an equal. So this is going to have two parts, the outline and the filling. Okay, so x is greater than or equal to 15. So I'm going to go to 15 and put my filled in point, and then my ray travels to the right because it's greater than or equal to 15. So it's 15.1, 15.2, 16, all the way up to 1,000,000. And then same thing for less than or equal to. We're going to start with a filled in point, and it will travel to the left, just like less than did here. X is less than or equal to 10. So I'm going to put this point right here, and then it goes to the left, including everything that is less than 10. On and on with this arrow on the ray. Okay, so I put homework 514 in the email for you, and then I also included another practice sheet that's just graphing these. So just make sure that you're paying attention to if you have a hollow point or filled in, and which direction it is that that's traveling. And just talk yourself through it. Like, this needs to be greater than 1. Is your ray encompassing everything that's greater than 1? You should be able to catch if you've done it in the wrong direction. Okay, and so we will go over this on Tuesday on the Zoom. So if you have any questions, come with those, and have a great weekend.